We're going to continue with Section R1 on page 25 again. At the end of the last recording, we went ahead and looked at this chart. And remember, this chart is kind of like a family tree, that if you have a line connected to anything, that you're connected to the family that's above you. So if you look at the far right and you take the number like 2, which is a natural number, that number is a natural number, it's a whole number, it's an integer, it's a rational number, and it's a real number. It belongs to every group or every box that it's connected to going up. Again, the most important one for us here is the term integers, because that is one of the problems on the practice test, that you have to name the integers between a certain 2 points, and there will be one of those on the test as well. So those are going to be the negative whole numbers, 0, or the positive whole numbers, depending on what the two numbers that we're dealing with are. On page 26, we continue looking at the real number system. Numbers are either rational or irrational. Rational numbers are the ones that can be expressed in the form of a fraction, p divided by q, where p and q are integers. We just took a look at integers, or the whole numbers, and the bottom of that fraction cannot be equal to 0. We cannot divide by 0. Examples are the number 0 itself, because 0 divided by 1 is 0, 0 divided by 2 is 0, etc. 4 is a whole number, and 4 divided by 1 is written as a fraction is equal to 4. 8 divided by 2 is also equal to 4. If we have what looks like a fraction, the 1/4, which is 0.25, it's a terminating decimal. All terminating decimals that end are rational numbers. 1/3 is if you try to divide that. The 3 keeps going on forever, so we could express it as 0.33 with dots after it. More normally, what it is written as 0.3 with a single bar over top, the digit that repeats. Here it's over both 3's, but it's the same whether it's over 1 3 or over 2 3's. Irrational numbers are numbers that in decimal notation neither repeat nor terminate. Pi is one of the most famous ones that we use. The square root of 2 is an example of one that doesn't have any repeating blocks. We can represent it as we have here, but that number is not an exact number. And then example C, 5.12, 122, etc. It has a pattern, but it is not a repeating pattern of blocks. On page 27, we tried to model the real numbers by using what's called a number line. And we draw a horizontal line and divide it off into spaces. The numbers going to the right are positive numbers, the numbers going to the left are negative numbers. The order of numbers can be determined from the number line. -3 is to the left of 0, so -3 is less than 0. Here we have it expressed as -3, and there's a less than sign. It's the one where it has the point is pointing toward the smaller number, and the open space at the end of it is pointing toward the number that's larger. So in A, that one is red, -3 is less than 0. On B, 4 is to the right of 2, so 4 is greater than 2. On B, we have it expressed as 4 is greater than 2 with the symbol, the V turning on its side again. Again, it's pointing at the smaller one, and the bigger open spot is by the larger number. On example C, we have an example of a less than sign, but it also has a single line underneath of it which indicates equality too. So it is read A is less than or equal to B. It actually means that A is either less than or equal to B. So if we have 4 is less than or equal to 5, this part is true because 4 is less than 5. 5 is less than or equal to 5 is true because the part of it that's true is that 5 is equal to 5. It of course cannot be both at the same time. It indicates that it is either less than or it's equal to the other number. On D, it's similar except we use the greater than sign. It is read A is greater than or equal to B. Again, it means that A is greater than B or A is equal to B, one or the other. 5 is greater than or equal to 4 is true because 5 is greater than 4. 5 is greater than or equal to 5 is true because 5 equals 5. On page 28, we're going to look at something called interval notation. It's on page 3 of your textbook. Sets of numbers can be expressed using something called interval notation. On the number line that we have illustrated below, if we put a parentheses over top the -3 and we have a parentheses over top the +4, the parentheses are used to indicate when the point is not included in the interval. So it includes all points up to the point of -3, but it does not include -3. It includes 3.5, 3.6, 3.7, 3.8, 3.9, 3.99999, but not 4. So we have the picture drawn on the number line. If we have it represented in interval notation, what we do is we just drop essentially the number line out and list both endpoints, with the smaller endpoint being to the left. So parentheses, -3, 4, close parentheses is the interval notation, which means all numbers between -3 and 4, but not including the -3 and not including the 4. So parentheses are used when the point is not included in the interval. Another way of expressing the same thing is something called set notation. And set notation is the one in the middle of your screen. Interval notation is the parentheses, -3, 4, close parentheses. And after the equal sign there, you see a squiggly bracket and an X, a vertical bar, and then -3 is less than X and X is less than 4. That's called set notation. The way that it is read is the set of all X, so that's how you read the squiggly brace, and the X is the set of all X. The vertical bar is read such that, and then you read the condition. So it's read the set of all X such that -3 is less than X and X is less than 4. So we have three ways to represent the same thing. The graph above is the graphical representation of it. The set with the parentheses around it is the interval notation, and the one with the squiggly braces around it is represented as set notation. The example that you see listed here, where it has the number line and an A and a B on it, is actually using algebra. So we don't know what A and B are. Like above, we knew that the -3, and we knew the 4, and we knew that -3 was less than 4. Here all we know is that A is less than B. A could be the -3, and B could be the 4 that was above, but we don't know what they are. It's using algebra. In interval notation, it's listed as parentheses A, B, closed parentheses. That's interval notation. In the set notation, it's a set of all X such that A is less than X and X is less than B. On page 29 of your lecture notes, we have an example of where the point is included. So at this point, we don't know what A is, but A is included in our picture and everything to the right. So there's a number line. In interval notation, it would be written as a square brace A, infinity. The little symbol that you see that looks like a figure 8 on its side is the infinity symbol. Always with the infinity symbol, we always use a parentheses. In set notation, it would be the set of all X such that X is greater than or equal to A. So an example of this would be our grading scale. If you receive 1,080 points or anything more than that, you would receive an A for the class. So you could think of the point as A as being the point 1,080. If you get exactly 1,080 points or anything greater than that, you're going to receive an A for this class. Here's another example where the point that's included is -2 and everything to the right. So there's a graph of it, there's the interval notation, and there's a set notation. The three most important things to remember when trying to graph or use interval notation or set notation are these listed at the bottom. When the notation includes the point in the graph and the interval notation, you're going to use a square brace. For set notation, that's going to be a greater than or equal to sign or less than or equal to sign. When the notation does not include the point, then you use a parentheses. So the graph and the interval notation will use a parentheses. The set notation will use strictly a less than or strictly a greater than sign. When you have an interval which extends toward infinity, you will always use a parentheses with the infinity sign. And the rest of this lecture has pairs of numbers, one listed in algebra and one listed with numbers, and different examples of how to use intervals, graphs, and set notation.